All right, our next way that we're going to solve quadratic equations is by factoring. So far we've looked at solve by graphing, where we look for x-intercepts. We've solved using square roots, where we can basically just take the square root of both sides and use that as a way of solving for x. Our third method is factoring. So I can solve a quadratic equation written in factored form first, and then we'll look at the ones that are not written in factored form and talk about how to do that. So when we see an equation like this, y equals x minus 3 multiplied by x plus 4, keep in mind that the first binomial, so the thing that's in parentheses, is a factor of this quadratic. Then the x plus 4 is a second factor of the quadratic. Now, as a little warm-up, I want you to think about how you would answer this question. So if a multiplied by b equals 0, so a times b equals 0, what must be true about the value of a or the value of b? Any ideas? Another way to put it is, if you're going to multiply two things together and get 0, how is that possible? Well, I can't multiply a positive number times a positive number and get 0. That doesn't work. I can't multiply a negative number times a negative number and get 0. That also doesn't work. And when I multiply a positive number times a negative number, that also does not equal 0. So the only way that we can multiply two numbers together and get 0 is if we use the number 0 as one of our factors. So it's either 0 times some number, doesn't really matter what that other number is, or some number, I'll just say it's positive, times 0 equals 0. Or I guess possibly 0 times 0 equals 0. So what must be true about this? Well, either the first factor has to be 0 or the second factor has to be 0, or quite possibly both factors could equal 0. That concept is what we call the zero product property. If when multiplying two factors and it equals 0, then it's either the first factor that equals 0, or the second factor. So let's use that zero product property, the ZPP, to solve this equation. And we'll check our answer, of course. So in our first example, we have x is the first factor, and x plus 4 is the second factor. And when multiplied together, it equals 0. The zero product property tells us then that either the first factor of x or the second factor of x plus 4 has to be what equals 0. So all we do is we take each factor, whether it's binomial or monomial, write it separately and make it equal to 0. Now we should solve each of these equations if necessary. Now my first equation, just x equals 0, x is already by itself. Okay, so 0 is one of my possible answers here. But with x plus 4 equals 0, I would need to subtract 4 on both sides to get my final answer, x equals negative 4. So these are my two solutions. X could be 0, or x could be negative 4. Now, if x is 0, let's just plug that in so you can see what happens. If x equals 0, we would get 0 multiplied by 0 plus 4, which would make it 0 times 4 equals 0, which is true. If we check our other solution, when x equals negative 4, let's see, that would be negative 4 as the first factor. And then our second one, negative 4 plus 4, is 0. Okay, so that explains how we get 0 that way. It makes the second factor a value of 0. So either one of those two would be solutions, x equals 0 or x equals negative 4. Here's another example. We have our two factors. Together, when multiplied, it equals 0. So that means either the first factor has to equal 0 or the second factor has to equal 0. Either one. We solve in each case by using inverse operations. So I subtract 4 on the first one. I add 3 on the second one. It's okay. You're going to end up doing different things for different equations. And I'm going to get x equals negative 4 as one of my solutions, and x equals positive 3 as my other solution. Let's try this one. If 3x minus 5 is the first factor, and x plus 6 is the second factor. So we take each factor, 3x minus 5, x plus 6. We set each factor equal to 0, and we solve. Let's see, I'd have to add 5 first on this one. I get 3x equals 5. Let's see, I'd still have to divide by 3 to get x by itself. And I can't divide 5 by 3, at least not without using decimals. And if I divide, I think it's like 1.66666 repeating. So I think I actually would rather leave that as 5/3. In my second example, I would just subtract 6 from both sides, and I get x equals negative 6. That one's a little bit easier. So those are my two solutions. If I were to plug 5/3 in for x in the first factor, it makes that equal 0. If I were to plug negative 6 into the second factor for x, it would make that equal to 0. So that's how we get our solutions, using the zero product property. All right, so let's talk about when our quadratic is not in factored form, okay? Because our goal up above says, let's get it to factored form so we can use the ZPP, the zero product property. So when we have an equation like this example, the first thing we want to do is try to get it to standard form if it isn't already. Remember, standard form is that ax squared plus bx plus c equals 0. So the big thing is make sure you've got your x squareds first, your x's second, your constant terms third, and then finally it's got to be equal 0. If it's anything else, we have to do some adding or subtracting to move things around. All right, so this one's in standard form. We're ready to go. Step 2 says to factor the quadratic. So thinking back to a previous unit, we want to see how do we factor x squared minus 6x plus 9. And this is one of those cases where we use the area model to factor. So we've got x squared in the first box. The minus 6x, you might remember, is when you add together the like terms. And the positive 9 goes in the last box. So we factor the x squared, and then we think about what possible numbers will give us 9. So what multiplies up to 9, but also will add up to negative 6, because that's our middle coefficient. So you can, guess and check or use your combinations here. 1 times 9, 3 times 3, negative 1 times negative 9, negative 3 times negative 3. And again, we're trying to get it to add up to that number. Well, let's see. It's got to be two negative numbers to add up to negative 6 in this case. Looks like it's going to be negative 3 and negative 3. So do minus 3, that multiplies up to 9. And just double check the rest. It's negative 3 times x, negative 3 times x, adds up to negative 6x. There we go. So it looks like it's x minus 3 as one factor, so that's our length. And then x minus 3 is the other factor, that's our width. So it's just a little review of factoring from, I believe it was unit 9. Now we can use the zero product property. Say, well, okay, so x minus 3 is one of my factors. X minus 3 is my other factor. Make each one equal to 0 and solve. And actually, I probably only have to solve it once because it's the same thing. I'm going to get the same solution because it's the same thing. Add 3 on both sides. So x equals 3 is actually a double root on this one. It's the only answer, but it counts as a double root. X equals 3. So let's do that again. It's really just a review of factoring more than anything. Now in this example, it's not actually in standard form yet. Remember, standard form would say equals 0 at the end. So if it says something like this, where we have a number other than 0, just add or subtract it to move it over to the other side. So this is going to become, so we have x squared plus 4x minus 5. I didn't have any like terms. I couldn't combine them. It just, rather than standard form. And then 5 minus 5 is 0. So I'm trying to figure out how to factor is x squared plus 4x minus 5. So I know x squared goes in the first box. I know the minus 5 goes in the last box. And I have to try to figure out how those other two then would add up to 4x. All right, so let's factor what we know. We know x times x is x squared. Well, we also know that 1 times 5 is the only way that you can get 5, but one of them has to be positive, one of them has to be negative. Let's see. It adds up to a positive 4x, so that means I need the bigger number to be positive. So that's the positive, and then the 1 is the negative 1. Let's check the rest, though. Negative 1 times x, positive 5 times x. Add the like terms to get positive 4x. Okay, so we have our two factors. It's x plus 5 and x minus 1 as our two factors. So now that we have our factors, basically when you multiply the factors together it equals 0, we can use the zero product property. So either x plus 5 equals 0 or x minus 1 equals 0. Solve to find each value for x. So the first one's going to give us x equals negative 5. On the second one we solve and we get x equals positive 1. Those are the two possible values that would solve our quadratic equation from the beginning. We'll make it a true statement. Let's take a look at another one. We have x squared minus 4x minus 12 equals 0. Okay, because it says equals 0, we know it's in standard form already. So now we're ready to factor that quadratic. So let's use our area model. We put x squared in the first box, and this time negative 12 in the last box. And we're trying to find the right combination, so factors of negative 12 that are going to add up to negative 4. Okay, remember that. They have to add up to negative 4, but also multiply to negative 12. So let's see, 1 times 12, 2 times 6, 3 times 4, and then let's see, I have to have one of the numbers negative, one is positive in each pair. And because they add up to a negative, that tells me the bigger number has to be negative. So I can make those negative over here. These are the positives. Okay, so there's my 3 pairs of numbers that will multiply up to negative 12, but add up to a negative number. But the only one that adds up to negative 4 is these two. So 2 times negative 6 is negative 12. So positive 2 times negative 6 is negative 12. We're good there. And then we have, let's see, 2 times x, negative 6 times x. Added together gives me negative 4x. So we write our factors, which are represented by our length and our width. So x minus 6 is one factor, and x plus 2 is the other factor. And now we can use our zero product property. So either x minus 6 equals 0 or x plus 2 equals 0. In either case, we use inverse operations to solve. We get x equals 6, and we get x equals negative 2 as our two solutions. Those are the two values that would make our quadratic equation equal to 0 on both sides.